Very good day. Today we will study some chemistry. Talking about chemistry, people think it is very tough, but no, it's very easy. We will start today with acid, bases, and salts, a very easy topic. Look at the pictures I am displaying to you right now on your screen. Some of them are very sour to taste. Some of them are sour to taste and mouth watering. Over here, you can't taste it, but this produces lot of foam. It is very soapy to touch. Such substances are classified as acid and bases. We'll study them in detail now. I am going to take examples of two molecules. One is HCl. The first molecule example is HCl, which means hydrochloric acid. Hydrochloric acid gives me H plus radical and I'm getting Cl minus radical. I am going to take another example, that is HNO3. This molecule is nitric acid. Nitric acid gives me H plus and I'm getting NO3 minus. Now you see two things common in the reaction, that is H plus in the both example. So these are nothing but the basic radical. H plus is known as the basic radical. So the compounds that have basic radicals in their molecules are called as acids. Okay, so in a reaction one is basic, तो बचा हुआ acid रहेगा. Yes, HCl minus and NO3 minus are the acidic radicals. So acids have common thing, that is, take two more examples. I'm taking NaOH, which means sodium hydroxide. Sodium hydroxide gives me Na plus radical and I'm getting OH minus radical. Let's see example number 2. I am taking KOH, which means potassium hydroxide. That gives me K plus radical and gives me OH minus radical again. So you see the common things, common molecules right here is OH minus radical. So we get OH minus radical again. These radicals, OH minus, are acidic. These are acidic. So, in short, the compounds that have acidic radical are called as bases. Okay, so अभी acidic रहेगा तो बचा हुआ base रहेगा. So Na plus and K plus becomes the basic radical. Okay, so now we will see what is ionic bond. Now talking about ions, we have two ions, that is cation, and we have another one, that is anion. Okay, and cation is always positive, anion is always negative. Now sometimes you get confused, like who's positive and who's negative. So what we got to do is we have a little trick to remember which one is positive and which one is negative. You see in cation, the spelling, the T basically, cation is positive. Like I'm just giving you a little trick to remember which one is positive and which one is negative. Cation is positive and anion is negative. You see there's a small tiny little plus sign hidden in the spelling of cation, and here you have small minus sign hidden in the spelling of anion. So the size of cation is always smaller and the size of anion is always bigger. So why is it so? This is because cation is positive, it loses away electron, and as we know electrons are negative in nature. तो अभी negative in nature मतलब कहाँ पे जाने वाला है ये? It will go to its parent. ठीक है, who's इसका parent कौन होगा? His parent will be the negative sign. So cation, then electron will always go towards anion. Okay. So because cation is losing the electron, पूरा electron shed कर रहा है वो, that is why it is smaller in size as compared to anion, and that is why. So this is the matter of size. Now we will see what is ionic bond. Ions we have two, cation and anion. So there is a bond formation between cation and anion, and we will see this with the help of example. I am taking sodium Na and I am taking chlorine. So we will see the ionic bond formation between sodium and chlorine. Okay. Here we will see with the examples of sodium and chlorine, where sodium is cation and chlorine is anion. Atomic number of sodium is 11, which has 2 electrons in innermost shell, 8 electrons in the second shell, and 1 electron in the outermost shell. In order to gain stability, that is 8 electrons in the outermost shell octet, sodium needs to lose 1 electron, which is easy than gaining 7 electrons. Chlorine, atomic number 17, 2 electrons in the innermost shell, 8 electrons in second shell, and 7 electrons in the outermost shell. Over here, chlorine needs to gain 1 electron, which is easy than losing 7 electron in order to gain the stability, to have 8 electrons in the outermost shell. So sodium donates 1 electron to chlorine. So they both are stable now. And sodium has donated 1 electron to chlorine, so it gains positive charge. And because chlorine took 1 electron or gained 1 electron, it gains negative charge. So over here both become stable compound. NaCl is a stable compound now, and the bond is the ionic bond. So here we go for our experiment time. I have two glasses filled with water, glass A and glass B. I am putting sand in glass A and some salt, common salt, table salt NaCl in glass B. In glass A and glass B, which do you think is going to dissolve in water? Salt in water or sand in water? Which one? So in the experiment we saw that salt mixes very well with water. We now have the molecule of sodium and chlorine, that is NaCl. We will see now what exactly happens when salt mixes with water, where we have H2O molecules. Now what happens? In the H2O molecule you have oxygen, which is highly negative in nature. The negative nature of the oxygen, it pulls out this positive sodium ion. As we know, opposites attract each other. In the same way, hydrogen is positive in nature, so hydrogen pulls out chlorine ion. So the NaCl molecule breaks, the ionic bond breaks and dissociation occurs. Now we will see how to write this reaction. Salt dissolving in water, NaCl plus H2O. NaCl, we will write the state, that is solid. We know that salt is solid in state, and we have water which is liquid in state. So we'll write this all in the reactant side, okay, and whatever the product will be formed, we will write in the product side. As we know, left hand side of the arrow and right hand side of the arrow. Next, NaCl will give you Na plus and will give Cl minus. But these things are dissolved in water, so not to forget to write H2O over the side. But you can also write as the aqueous in the bracket below the two ions. Aqueous, which means dissolved in water. And when you write aqueous, you need not write the H2O part. I hope you enjoyed the lesson. We will study many such topics in the next lecture, like Arrhenius theory, strong acid and weak acid, in a very fun way. That's all. See you next time, and please keep referring your textbooks.